Okay, we're gonna take a look at 6-2, and we're gonna start with a warm-up. This is basically, we're gonna be multiplying and dividing rational functions here. So just a little warm-up of starting how to multiply fractions. So the first thing that we learn is you can multiply straight across and get 20 over 60. But then we have to reduce this, right? So what is 20 over 60 reduced to? 1/3. Now, there's actually an easier way to go about this, which is canceling stuff first. So understanding that we can go, that we're going to go straight across and that this becomes basically one fraction, and then we can cancel stuff out from here right in front. So this is a normal way and it totally works, but what it is it's taking smaller things, making them bigger, and then reducing, right? Whereas another way of doing this is, let me just make a copy of this. So another way of doing this would be to right here, understand that this is one big fraction, and cancel out the 4. This becomes a 1, this becomes a 1. Then the 5 over 15, this becomes a 1, and this becomes a 3. And hey, would you look at this? We don't have to do any of that multiplying or any of that simplifying. We can just get it to 1/3 right away. So it's actually better to cancel first. Okay. As far as dividing, I wrote up this bit over here. These will be in the full notes. But this is from our very first section, 1-1 Basics of Algebra, and I pulled out two things from there. 1 over b means the reciprocal of b. It's definition of, we talked about inverses, multiplication inverses, what you use to get the identity. So this notation 1 over b means the reciprocal. Also, a divided by b, this is the definition of division, means multiplying by the reciprocal. So this is where that notion of keep, change, flip comes from. So whatever way you think of it, we're going to keep the first fraction, change division to multiplication, and flip this second one over. And now this is a problem like we had before. Now again, we could multiply this to 42 over 63 and reduce that, but let's do the thing we did last time, where we have divide these two things by a 3, these two things by a 7, and our answer is 2/3. Okay, so hopefully those will also help with the 6-0, the delta math. So to summarize, what we're gonna do to multiply two fractions, you multiply straight across, and don't forget that you can also cancel out common factors. Mathematically, what this means is if we have a over b times c over d, this is equal to one big fraction of a times c over b times d. To multiply or to divide two fractions, we multiply by the reciprocal. And here, this is, if we have a over b divided by c over d, we can keep, change, and flip. So that's really the crux of these notes, is just remembering how we multiply and divide fractions, but we're gonna knock it up a notch and do this with polynomials. So we're still going to be doing the stuff that we did from last section of stating the restrictions and stuff like that. And remember to do the restrictions before you cancel anything out. So when we do this, again, we can just think of this as one fraction, but I'm going to show this work here where this is 5 times 9 times x on top, and down here we have 18 times x times 2. And before I multiply anything, I'm going to cancel some of this stuff, right? So these x's can go away. This 9 becomes a 1, the 18 becomes a 2. And look, this is 5/4. So this reduces to 5/4, but I actually just did something I said not to do. What was that? What do you have to do before you cancel stuff out?
Find the restrictions.
Find the restrictions. So let's pretend like I didn't do this, and what value of x would make the denominator equal to 0?
0.
Yeah. So x cannot equal 0. So what that means is this multiplication problem is going to always reduce to 5/4 no matter what I plug in for x, unless we put in 0. Okay? All right, so same thing. I didn't do the thing that I normally do where I like do a warm-up problem and have you factor some things, but that's okay. We can do this real quick. Let's see, the tops are fully factored. 3x squared minus 8x minus 60. Let's just do that on the side. Let's see, 2 factors of negative 180 that add to negative 8. What would that be? Oh, that would be 18 and 10, right? So 3x squared minus 18x plus 10x minus 60. 3x parentheses x minus 6 plus 10, x minus 6. So this reduces to 3x plus 10 and x minus 6. We can cross this out and put that there. The 8x cubed plus 1, that is a difference of perfect cubes. This is going to be 2x plus 1 and 4x squared minus 2x plus 1. So let's look for our restrictions. I'm just going to put that over here. What can't x be? What do you got?
6.
Yep.
Negative 10 over 3. Or is it
Yep, negative 10 thirds.
0, I'm guessing.
Negative 1/2. 0, no guessing. There's no x in front. 0 is actually totally allowed. You can plug in 0 to this. One thing to note, if we were to plug this into our calculator, into our quad formula, and do this, you would get imaginary answers. So when you do this, you'll get one rational 0, which is negative 1/2, and this part is going to be imaginary. B squared 4 minus 4ac, that's 4 minus 16 is negative 12. So now that we've done that, now we can cancel stuff out. We get the 2x plus 1 cancels out, the 3x plus 10 cancels out. Everything went away from the top. What do we do?
Add a 1 or have it.
Yeah. So if everything disappears, that means that this 1 that's been chilling up here and been invisible now has to become visible. So we have a 1 on top, and we have x minus 6, 4x squared minus 2x plus 1. And this is our answer for this guy. Okay. So this one, I'm going to go ahead and factor all these, and in the next one, I'm going to flip the factored version. So a squared plus 2a minus 15, that would roughly be a plus 5 and a minus 3. A squared minus 4 would be a plus 2 and a minus 2. So when we do this, we keep the first fraction. So that is a plus 5 times a minus 3 over a minus 3. Change this to multiplication, and you flip this fraction. So this would be 2 over a plus 2, a minus 2. Now, one thing to note, your restrictions with division can come from here or here. Notice that in the first problem, all we have is a can't be 3. But if something made this 0, we'd have to get that as a restriction. And when we flip it, now we get 2 more restrictions, right? So our restrictions here are a cannot equal -2, 2, or 3. And when we cancel here, we get the a minus 3 goes away and nothing else. So we have 2 times a plus 5 over a minus 2, a plus 2. And that is our answer. Factored form is totally fine for this stuff, so no need to multiply this out or anything like that. And the last one, let's see, we've got a lot of factoring to do. River, will you factor this bottom one down here?
Yeah.
I'm gonna work on the other two. So let's see, this is -20 that add to 1 is 5 and -4, 2x squared. Okay, so this one is 2x plus 5 and x minus 2. -4 that add to 15 is, well, that would be 6 and 9, but it's supposed to be negative. -3 and 18, which is what'd you get for this one, River?
2x minus 3 times x minus 6.
Okay, I buy that. So, what we have is here, I'm gonna make these things bolder. Oh, that's too bold. Nope, more than that. Hey, whoa, what is going on here? 10, yikes. Let's try that one. All right, cool, that looks a little better. All right, so from this one, we're gonna actually have 2 passes at our restrictions. We are gonna get restrictions from here, and then we're going to flip it and also get a restriction from the bottom here. So as it looks at the beginning, our x's cannot be -9, 3/2. We've got 3/2 again, and 6. But then what happens is we flip this, and we get 2x plus 5 times x minus 2 over, why am I doing this when I have the power to just copy it? And then we're going to change this to multiply, and we're going to flip this guy over here. So we're going to get, this one's for Trevor, this John over here, and Toby. Miss you guys. Wish you were here. So these guys on top, and 2x plus 5. There is an implied parentheses here. So now let's go through and cancel. Right, before we do that, we do get another restriction. Now this also can't be -5/2, right? And so this cancels out, this cancels out, and that's everything. So we're going to be left with on top x minus 2, x minus 6, and on bottom x plus 9. And I'm just going to copy our restrictions down here, and we're done. So that is how these ones go, multiplying and dividing rational expressions.